Okay guys, so I want to review two-step inequalities with you. I'm going to go ahead and give you these notes before we kind of talk about them in class. But we reviewed a little bit of solving one-step equalities, but this following two-step inequalities follows the exact same process. So you can go ahead and either fill your notes in on your hard copy from this video, and I'm also attaching the digital copy to the Google Classroom, so you have two options. You can either copy and paste into your digital notebook, or you can jot down everything in your hard copy of your notebook. Remember that we have a notebook quiz coming up, so that is why we are doing this video, just trying to get ready for that. So two-step inequalities follow the same process for isolating the variable, so we're still trying to get the variable, so that's the letter by itself. Usually X, but you can see any variation of letter. You are going to think of it as undoing operations. And again, solving two-step inequalities, the first step is to undo addition or subtraction with the inverse operation. You can undo multiplication or division with the inverse operation. And when you multiply or divide by a negative number, the inequality sign is flipped. You have to watch for negative signs, because again, when you divide or multiply by a negative, you will change the direction of the inequality sign. Isolate the variable and then check the inequality sign again. Okay, there are two problems underneath. I'm going to let you leave those blank for now, because when we do talk about inequalities in class, we're going to come back and we're going to fill those in, so you don't have to worry about that for the video. And then we move into writing inequalities. So 7.10a is to write one variable two-step equations and inequalities to represent constraints or conditions within problems. So I might give you a little bit of, I might tell you something, give you like a problem-solving situation, and you have to come up with the equation or the inequality that goes with those constraints. And that'll make more sense in a second when I show you an example. And then you will write a real-world problem given a one variable two-step equation or inequality. So slide 3 moves into some of those situations that I was just telling you about. But for writing inequality, you are taking a verbal statement and translating it into an algebraic inequality. It's kind of like deciphering a secret message or translating from one language to another. So these are some typical inequality phrases that you would see. So we have our less than symbol, and that usually means less than, smaller than, below, fewer than, those types of things. We have the greater than symbol, so that can mean more than, greater than, above, exceeds, larger than. And then remember that we have the less than or equal to. So this can mean maximum, at most, no more than, or less than or equal to. And finally, we have our greater than or equal to symbol. So this can mean minimum, at least, no less than, or greater than or equal to. And then, guys, I did this by writing in a Jamboard and then snipping it out. So you will say a number is at most 15. So X is less than or equal to 15, because remember, at most was one of the words that went up here with less than or equal to. Okay. Number 2, the sum of a number and 3 is less than 12. So X plus 3 is less than 12. And I know my handwriting isn't perfect. I was writing with my mouse, so I apologize for that. Number 3, the quotient of a number and -2 is greater than or equal to 10. Okay. So X divided by -2, because that's when we talk about a quotient, we're talking about division. X divided by -2 is greater than or equal to 10. Okay. Number 4, 4 less than a number is at least -6. So X minus 4 is greater than or equal to -6. The difference between a number and 13 is at least 1. X minus 13 is greater than or equal to 1. Number 6, 8 less than a number is less than or equal to 5. So X minus 8 is less than or equal to 5. So we're just taking the words and writing them with our variables in our inequality signs. Number 7, 3 times a number is more than negative 7. 3x is greater than negative 7. 8, 1/2 of a number plus 5 is greater than 11. 1/2 of x plus 5 is greater than 11. Number 9, negative 6 plus a number is less than or equal to 15. Negative 6 plus x is less than or equal to 15. Okay? And then your copy of these next notes has 6 problems. I think that you can pretty much get the gist of it from the 3. But we solve an inequality just like we solve an equation. So we're going to set it up the same way. We're going to draw our line on top of the sign so that we can keep things organized with the left and the right hand side. So the sum of twice the number and 4 is at least 16. So 2x plus 4 is greater than or equal to 16. Okay? Then I rewrote my inequality, and I'm going to solve it just like I do an equation. I'm trying to isolate that variable. I'm trying to get the x by itself. So the way that I do that first, when I have a positive 4, is to subtract 4 from both sides of my equation. That would give me 2x is greater than or equal to 12. Well, now the inverse operation of multiplication is division. So I divide each side by 12, and then that gives me x is greater than or equal to 6. So when I go down here and I try to graph my solution, remember, since it's greater than or equal to 6, it gets a closed circle because 6 is included in my possible numbers that would fit this inequality. So 6 is greater than or equal to 6. 7 is greater than or equal to 6. 8 is greater than or equal to 6. It could be 53 because remember that arrow just keeps going and going and going. Okay? And then for my next 2 examples, I followed that exact same process. I started with the inverse operation of addition or subtraction, and then moved on to the inverse operation of multiplication or division. And remember, the goal of to solving an inequality means there can be an infinite number of solutions. It doesn't have to be just one. Okay, we're going to talk about this more in class next week, but I wanted to give you a little preview, and I wanted you to be able to update your notes this weekend. Or if you are my 5th and 7th period, you will be doing this on Monday evening. Either way, have a good weekend or have a good Monday night. See you guys later.